Most people assume their computer only connects to the internet when they ask it to. You open a browser, you visit a website, you check your email, simple enough. But underneath that calm surface, something else is happening. Applications are making connections all the time without ever telling you. This is the invisible data problem. Any application on your system can open a network connection silently, without asking for permission, without showing any notification. The device sits on your desk, technically yours, but the software running on it has other ideas. Vendors can push silent updates whenever they want, running whatever code they choose with whatever privileges the app happens to have. You might trust the software you install, but do you really know what it is doing in the background? Christian, one of the developers behind LittleSnitch, felt this acutely. When he started exploring Linux on his Mac, he had grown accustomed to watching every connection, seeing exactly which process was talking to which server on Linux. He had nothing. He described the feeling as being naked. It is a strange sensation, he said, to have no idea what connections your computer is making. Now, Linux users might point to app-firewall or other traditional firewalls as a solution, but those tools operate at the wrong level. They control ports and IP addresses, not applications. A firewall can block outgoing traffic on a certain port, but it cannot distinguish between your browser checking email and some background process sending telemetry data to a server. You have never heard of the distinction. Matters. You might want your browser to connect, but that does not mean you want every app on your system phoning home. This gap between what we think our computers are doing and what they are actually doing is exactly what LittleSnitch was built to address. For years, objective development software kept their focus narrow. Based in Vienna, Austria, they built LittleSnitch exclusively for macOS. Their customers were Mac users, and the business model was straightforward. You paid for the software, and it gave you control over what your applications were doing online. But something shifted recently. In announcing the Linux version, the company made their reasoning unusually clear. They pointed to political events that have pushed governments and organizations to seriously question their dependence on foreign-controlled software. The phrasing is deliberate. A European company is watching the tech landscape and seeing risk in platforms owned by companies in other countries. Linux offers something different. No single company controls it, no single country owns it. For a company thinking about digital sovereignty, that matters. What's striking is the price tag, or rather, the lack of one. The Linux version is completely free. This from the same company that charges for their macOS product. The move is not about revenue, it seems to be about something larger. A belief that Linux represents a path toward independence from foreign tech giants. The developer who built this version, named Christian, described feeling exposed on Linux without the visibility he would grown accustomed to on Mac. He looked for existing tools and did not find what he needed, so he built it himself. The political undertones are hard to miss when a company explicitly ties a product launch to questions about foreign software dependence. They are making a statement. Linux becomes more than an operating system. It becomes a strategic choice, and objective development is putting their software behind that choice at no cost to the users who make it. When the developers at Objective Development finally got LittleSnitch running on Linux, they started counting, and what they found was striking. Over the course of 1 week on a standard Ubuntu installation, they counted just 9 system processes reaching out to the internet. 9 on macOS. That same measurement revealed more than 100 system processes making connections in the background. The contrast is hard to ignore. But raw numbers only tell part of the story. What matters just as much is what specific applications are actually doing. Take Firefox, for instance. It comes pre-installed on Ubuntu, and most users would assume that if you dig into the settings and disable ads and tracking, you have effectively silenced the browser's background chatter. Not so even with those preferences. Switched off Firefox still connected to multiple servers. The browser was reaching out for reasons that were not immediately obvious to the user. Then there is LibreOffice. The developers opened up LibreOffice Writer just to see what would happen. They expected the usual pattern of background connections that most modern software makes, but LibreOffice made 0 connections, none as they put it. That is quite unusual these days. This brings up an important point about cross-platform applications. If you install Thunderbird or Visual Studio Code on Linux, you might hope that the privacy benefits of the operating system extend to those apps. They do not. These applications behave more or less the same way, regardless of whether they are running on Windows, macOS, or Linux. The tracking and telemetry built into the software travels with it. The operating system underneath matters, but so does the software you choose to run on top of it. So how does LittleSnitch actually work on Linux? The answer lies in something called app-firewall, which stands for Extended Berkeley Packet Filter. Originally designed for packet filtering, app-firewall has evolved into a powerful technology that lets programs run safely inside the Linux kernel without needing to modify kernel source code or write traditional kernel modules. Think of it as a sandboxed environment where code can execute with deep system access, but within strict safety boundaries. But here's the catch: not every Linux kernel can handle what LittleSnitch needs to do. The software requires kernel version 6.12 at a minimum. Why that specific number? Because the 6.12 release brought significant improvements to something called the app-firewall verifier. This verifier is essentially a safety checker that analyzes app-firewall programs before they run, making sure they will not crash the kernel or do something harmful. The improved verifier in 6.12 can follow program logic more effectively, which means it needs to analyze fewer code paths to approve a program. Without these improvements, LittleSnitch simply would not be allowed to load its monitoring code. There is also an upper limit to consider. Right now, LittleSnitch works with kernels up to version 6.19. Newer kernels in the 6.19 series actually reject the app-firewall program due to changes in how the verifier operates. The developers are working on a fix, but for now, there is a compatibility window. Another crucial piece of the puzzle is BTF or BPF type format. This is what enables something called CoRE, which stands for compile. Once run everywhere in the old days, if you wanted to write kernel software that worked across different Linux distributions and kernel versions, you would need to compile it separately for each one. That is, because kernel data structures change between versions. BTF solves this by providing metadata about the running kernel's data structures and function addresses. LittleSnitch reads this information and adapts itself on the fly. No recompilation needed. Most major Linux distributions enable BTF by default. You can verify it is working by checking if a specific system directory exists at /sys/kernel/BTF. The main exception is kernels built for embedded systems or low-memory hardware, which sometimes omit BTF to save space in practical terms. This means LittleSnitch for Linux currently supports Debian 13, Ubuntu 25.0, for Linux Mint 22, Fedora 40, and Red Hat Enterprise, Linux 10. These all ship with kernels in that supported range and have BTF enabled out of the box. Now there is something important that needs to be said about this Linux version. Objective Development is very clear about it. They explicitly state that this is not a security tool that phrase matters because it sets proper expectations. The macOS version of LittleSnitch is marketed as a way to protect your computer, to give you control, to be a real barrier against unwanted connections. The Linux version simply does not make that claim. The reason comes down to how app actually works. The technology is powerful, yes, but it has hard boundaries built into its design. There are strict limits on how much information can be stored and how complex the programs can get. These are not arbitrary restrictions, they are fundamental to how the Linux kernel manages app programs. Here is where things get tricky under heavy network traffic. The cache tables that LittleSnitch relies on can overflow. When that happens, the system cannot reliably connect every packet to the process that sent it. The mapping breaks down, some packets slip through without being properly identified. A sophisticated attacker could actually exploit this limitation by flooding the system with enough traffic to overflow those tables. Someone could push packets past the firewall undetected. That is a real vulnerability, and it is why the developers are honest about what this tool can and cannot do. Christian from Objective Development put it simply. He said that from a feature perspective, LittleSnitch for Linux sits somewhere between LittleSnitch Mini and the full LittleSnitch. It is functional, it is useful, but it does not have the polish or depth of the macOS version, and it should not be relied upon as a security barrier. Think of it more as a window into your network traffic than a locked door. For Linux users who have been watching their network traffic for years, LittleSnitch is actually arriving as a newcomer to an already crowded field. The open source community built its own solutions long before Objective Development turned their attention to this platform. OpenSnitch was one of the first to answer that need, inspired directly by LittleSnitch's approach on macOS. It brings the same interactive firewall concept to Linux. When an application tries to phone home, you get a pop-up asking what to do. Portmaster takes things further as a complete privacy suite that enforces DNS over TLS on all your connections, meaning your ISP cannot see which websites you are looking up. PicoSnitch offers another lightweight approach, focusing on monitoring and logging without constantly interrupting your workflow. Wireshark has been the gold standard for network analysis for decades. It is not an interactive firewall, but a deep protocol analyzer showing every packet traveling across your network interface. It is overkill for everyday privacy concerns, but invaluable when you need to understand exactly what data is leaving your machine. What makes LittleSnitch interesting in this landscape is its web interface. Unlike traditional desktop applications, it runs a web-based dashboard accessible from another machine on your network. This is genuinely useful for home lab enthusiasts running servers. You can install LittleSnitch on a machine running Nextcloud or Home Assistant and monitor its connections from your laptop without constantly etching into the server. There is one catch: LittleSnitch for Linux is not fully open source. The app kernel program and the web interface are both available on GitHub, but one component remains proprietary. Objective Development has not specified which piece, but the result is a hybrid model that sits between fully open and fully closed. Whether that matters depends on your priorities.